Now we have talk from Chen Hui Jing, building light the way the web intended. Hui Jing is front-end developer at Shopify, a self-taught designer and developer with an inordinate love for CSS, as evidenced by her blog and her tweets. So we can start.
Dobry den. I'm very honored to be part of the lineup for Fwdays this year, and I understand that this is a JS+React conference, so think of me not as the main course, but something of a palate cleanser. A little something to refresh and activate a slightly different part of your brain. My name is Hui Jing, and I'm a front-end developer based in Singapore. I have a Chinese name, so my surname comes first and the first name comes last. These emojis represent who I am as a person, so you can ask me about them if you're interested. But the point of today is that I will be sharing with you about laying out content on the web. And honestly, regardless of which technology stack that you're using, odds are you will need to render and display content on a digital screen. And that screen could be any size these days. If your content is going to be rendered by a browser engine, then your main mode of communication with the browser for styling your content has to be CSS. And I'm sure everyone has their own opinion about CSS. Some of you might love it as much as I do, while others might see it of more of a hard-to-deal-with API that you'd rather much avoid. Regardless of your opinions on CSS, I'm not here to tell you how to think or what to feel. The reality is that browser engines today are much more capable than before, and they can lay out content much better than before, and we need to know how to make full use of the browser's web layout capabilities. Technology evolves really fast, I know, but as of today, most web interactions still involve a screen, and these screens can be as small as a watch face or as large as a 70-inch HD TV, and you, the developer, or designer, or creator, you can't really control this. This means the way that we think about designing layouts on the web cannot be like anything else that is fixed. It's quite a different mental model, and the tools that we use must suit this fluid and interactive medium. And luckily for us, now that Flexbox and Grid are well supported across all major browsers, our toolbox has been greatly upgraded. So Flexbox and Grid were introduced after the web started evolving to be more than just a document viewer. They were built to handle application interfaces which would be viewed across many different screen sizes. Back in the day before, Flexbox and Grid, if we wanted to lay out or size block boxes or inline boxes, we had to apply properties to the boxes themselves. Just use floats. As you can see in this example, width is on the item. If I use inline block, width applied on the individual item. Block and inline boxes, in a way, are not aware of the boxes around themselves. They care about themselves, and that's all. So in order to lay out boxes in a specific manner for an overall layout, you'd have to adjust each box individually. Flexbox and Grid operate on a parent-child relationship. So relevant display properties applied onto a parent container will affect the direct children within it. And the child items themselves have an awareness of their siblings within the same formatting context. But this relationship does not extend beyond the immediate child elements, so that's just something to keep in mind when you're debugging. Especially for those of you who work in code bases where you don't have full control of the markup, or if the markup is spread over different levels of nested components, for example. So when you set the display property of a box to flex, it creates a flex formatting context for its immediate children. Elements in the flex formatting context have a different set of behaviors from those in a block or inline context, and these include the fact that margin collapse does not occur in a flex formatting context. Floats and clears have no effect on flex children. Vertical align also, no effect at all. What does have effect is positioning, so you can still absolutely position a flex item, and that still works. But flex items are essentially flex level boxes, not block level boxes, hence this different set of behaviors, right? So the term flexible box, Flexbox itself, it's shorthand for flexible box, which means that the size of the Flexbox can grow and shrink and adapt based on the amount of free space that is available in the parent container. And this concept is completely different from what most web developers were used to when it was first introduced, and many folks, including myself, found it really hard to understand. This was because the size of the box was usually a direct reflection of the width or height values that we set on it, like you saw in the two examples before. But in a flex formatting context, the final size of the Flexbox may not necessarily be that value that you explicitly declared. Today we have the benefit of DevTools that can break down and show you what the browser is doing when calculating the sizes of the Flexboxes, and this helped me a lot, and I'm hoping that through today's talk I can help you understand this a little better as well. So let's just go back to the basics. The Flex property itself only applies to Flex items, and it specifies the components of a flexible sizing. So Flex is shorthand for three properties: Flex Grow, Flex Shrink, and Flex Basis. The specification actually encourages you to make use of the shorthand instead of the individual longhand properties, because this Flex shorthand resets the unspecified component values to accommodate the most common use cases. So when you apply display flex to an element, all the immediate children have their flex properties set to this initial 0, 1, auto, which means don't grow, flex grow 0. You're allowed to shrink, everyone can shrink together, flex at the same rate, flex shrink 1, and flex basis auto usually means your content size. We'll go deeper into this with a demo. Okay, let's see if this works. Gonna click. Okay. So, I want to go into explaining the three different properties and DevTools for, I'm using Firefox here. DevTools is a really big help in understanding all of this. So what you do is, for the most part, if you just want to see the overlay, Chrome and Safari also have the Flex overlay already. But so far, Firefox is still the only one that does this computation, which I find really helpful. Anyways, let's get into it. Let's first talk about Flex Grow. Flex Grow determines how much of the available free space ought to be distributed to a particular Flex item. So it's only relevant when the Flex container is larger than the total width of the Flex items. So in this example, I've set the container to 800, and the items themselves, 170, 140, 160, way smaller than 800. So this here is all available free space, 330 pixels of free space for distribution purposes. So this extra 330 pixels are distributed based on what the Flex Grow values are. So the default is 0, 1 auto, so nobody's growing. But if I set the grow value to 1 for everybody, so if you can see here, everyone has a grow value of 1. It's kind of like a ratio. So now that everyone has the grow ratio set to 1, they all grow by equal amounts. And so an equal amount of that 330 pixels is going to be split between these three. So when I click on this, you can, let me close this. When I click on the element, you can actually see the DevTools will tell you, okay, you started off at 170, but there was free space. So I'm giving that free space to your item. So I added 110 to it, end size 280. Same goes for the other three. 250 ends up 270. So it was not, the final sizes were not what you set originally, but it kind of is not that confusing to understand now that you've seen how the calculations work, right? So you don't have to have everyone set the same. So maybe, for example, if you want just the first two to grow, the last one to stay put, that means only A and B have a Flex Grow value. I set them to 1 just to make the math easy. But if you can see here, the 330 pixels of free space now get distributed between the two items, A and B. So everyone gets a 165. While C remains 160 because you told it not to grow. Flex Grow is 0, and that's how the end sizes of the your items are derived. So Flex Grow, I think, is reasonably straightforward to understand once you see the calculations. Flex Shrink, slightly more complicated. First of all, it's very similar to flex grow, but in the opposite direction. So this value determines how much a flex item should shrink so that it can still fit within the bounds of its parent. So it's only relevant when the width of the parent is smaller than the total width of all the flex items inside it. So there's kind of an algorithm for the calculation, and I'm hoping that through this explanation, you don't have to remember this. Please keep in mind, it's just a kind of a good to know situation. So if you have Firefox DevTools, you should be able to see the calculations. I chose these numbers so they were round, but for the most part, you probably see up to 2 decimal points, give or take. So if you don't want any shrinking to occur on your element, you'd set it to 0. But let's say the default, right? The default is 0, 1 auto. So by default, flex items will shrink. This is how it goes. First of all, you have to multiply the flex shrink value by the flex basis. And in this case, A, B, and C, their flex basis are their widths respectively. So for A, to calculate how much shrinkage is needed, you take the flex shrink value times the flex basis, divide this whole thing by the sum of all the flex basis values of all the flex items, and then multiply that by the total amount of space that needs to be shrunk, which is 300. Because 150, 450, 300, that's 900, and I set my container width to 600. So everybody needs to shrink by 300, and that's how the 300 gets allocated. Like, that's how much shrinkage everyone gets. And again, you can see this from DevTools. So 150, after the calculation, I'm like, okay, browser tells you, hey, you need to shrink by 50, and that's why the final size is 100. Same goes for the other 3. That's how flex shrink works. Again, don't have to memorize this because, you know, browser does it for you, but it's good to kind of understand the mechanism so that you kind of can figure out why your items are not the right size. The last one I want to cover is flex basis, and I feel that this property is key for understanding how sizing works with Flexbox. Flex basis determines the starting value of the flex item, which, depending on the situation, as I've explained above, the starting value might not be the ending value because all these calculations need to take place. The initial value of flex basis is auto, and usually this just means the content width. I said this. Well, I don't have borders because I want to see the overlay nicely. But yeah, so this is again a flex container with 3 elements with some stuff in it. And the longest sentence, if I got this right, yeah, it's about 455, 54.2. So this is without setting anything else on the flex items themselves, having a flex basis of auto tells the browser that, okay, the starting size for all my calculations for this long sentence is going to be 455. So, like in the shrink example, once I set a width value, although the width value then becomes the flex basis. So for example, here, I've chosen to set an explicit width of 300 on the last sentence. And so then its starting size, instead of being 455, it's now 300. 300 is where all the calculations are going to start from. In addition, if I have both width and flex basis set, flex basis value takes precedence. So for this last example, turn on the flex, highlight. The flex basis for this long sentence is 250, even though the width was set to 300. That's basically how flex basis works. So early on, when we talked about the growing, we talked about the concept of free space being whatever space left over in the parent container after accounting for the content sizes of the flex items. So this space taken up by flex items can either be the width of the content within the flex item. It can be, you know, the sum of all the explicit widths if you set them, and it could also be the size of the different flex bases. So a lot of options, hence a lot of different possibilities based on your inputs, right? However, there is a way to let the browser treat the entire parent container as free space to be distributed. So again, it lies with the flex basis property. So let's pick a standard example. Flex grow 1, flex shrink 1, auto, so everyone grew. All this free space was distributed evenly. But let's say we want everyone to be the same size. Possible. Possible with Flex. What we need to do is to tell the browser that everything in the parent container should be distributed equally. And to do that, you set the flex basis to 0. And when we look at the calculations, it says, okay, base size starts from 0. So content doesn't factor into the initial size. So what the browser is going to do is it's going to take the container, which in this case it's 810. 810 divided by 3, 270. Everybody is 270, ignoring the size of the content. So this is how Flex kind of behaves and how we can not control, but like kind of work with Flex to get some end results that we want. So I'm gonna pop back into my slides. Yes, excellent. So hopefully that kind of demystified some of the sizing stuff if you're confused about why your Flex boxes were certain sizes. But Flex also has a interesting new behavior introduced, which is you can change the directions of your content. And content flow is very closely related to the writing system being used. And most of us are familiar with horizontal top-to-bottom orientation used in English or Ukrainian, but writing systems can be left to right for Arabic or Hebrew. It can be vertical, right to left for Chinese or Japanese. Traditional Mongolian script is vertical but left to right, so lots of directions for content. Before Flexbox came along though, if you wanted to do content that flowed from an unorthodox direction, like bottom to top, it would almost be impossible. Or like, not without maybe using JavaScript, you have to like reorder the source or something. But with Flex direction, you are no longer limited to any particular direction at all. Any of the 4 directions are possible. So I'm gonna pop over to demo land again, all the way at the bottom. So the initial value is row. So row is gonna go with the main axis. So the main axis is the direction of content flow. And whatever is perpendicular, that's called the cross-axis. So in this context, it's English, horizontal, top to bottom. So initial value row. If you look at the source order, it's like 1, 2, 3, 4, 1, 2, 3, 4. That's very straightforward. If you change the flex direction property to column, then it flows column-wise, top to bottom, which is also as expected. But what's interesting is they also put in a reverse value. So what you can do is you can reverse the row value, and you can even column reverse the direction. And that's how, bottom to top content is now possible. I believe there are a lot of creative possibilities for this. I'm gonna leave that out there. If there are any creative designers out there, think about this. This is possible. You can combine it with animations. I don't know, But yeah, that's something I thought was really interesting about Flex. Let's move on. But as nice as Flexbox is, there is a limitation. So it's more accurate to say that it's something that Flexbox was not really meant to do, and that is to create actual grids that recognize a Y and an X axis. All the other layout models in the web only provide control within a single dimension. So every element in the layout model, every element in every layout model actually is laid out one after another, like and the only time that we can actually get something that looks like a grid is when we force all of these elements to be the same width. Then they kind of naturally line up. But if you look at even look at this diagram, right? Item 1 does not really know that item 5 is below it. Because once you change the size of your elements, odds are they're not going to line up nicely anymore. And so there's no concept of column. Grid systems built on these single dimension layout models rely on math. to get items to line up in rows. So a big reason why we had so many grid libraries back then was because the libraries would do the math for you. All you needed to do was put on the correct CSS class. But when we come to today and there's CSS Grid provides an actual two-dimensional grid. And you can place your items based on the row and column properties. So in a sense, it requires the developer or designer to have actually a clear picture of the entire grid structure so that the items can be sized and placed in the desired manner. So Grid introduces some properties and values that make building grids fairly more intuitive and convenient. So this is like the most basic of basic properties you need for a grid. You need these 3 lines. You need to put a display grid on it, and then you need to define your columns with grid template columns, define your rows with grid template rows. Syntax is also pretty visual. So I got 3 columns, 3 values, 2 rows, 2 values. Very cool. So okay, again, demo time. And I think it's nice to talk about all of these properties at once using a scenario building thing. So pop up. So our scenario today is that we want to have grid, 4 equal width columns, 20 pixel gap between each column. How would we do this? If we just use our 3 properties that we talked about earlier, it's possible, it's possible. So what you would do here is you would say, oh, okay, 200, arbitrary value, right? 200, 20, 220, 220, and then you have just grid rows. So this is how the code looks like, this is how your grid looks like. It's not great because essentially you're actually doing like a 7x2 grid. So it kind of works, but the issue is that the spacing between our main columns are really columns themselves. So you might accidentally get content in your gaps, and that's not really what you want. So there's a much cleaner way to do gaps using the gap property. So the gap property, again, introduced in the CSS spec. It's literally called gap because, I don't know, name things what it is, but you can just throw on a gap of 20. Your columns are now intuitive again because I wanted 4 columns, so I got 4 200 values. The gap is generated by the browser, and there will be no chance that you have accidental content in your gaps. But first 2, we were like, oh, we use fixed values, but I talked about all this fluid stuff. We want a responsive grid. So if we want a responsive grid, let's use some responsive relative values like percentages. Percentages are great for responsive. So 4 columns, I'm like, yeah, 100 divided by 4 is 25. So put 25 in. What is with this overflow? Why is it overflowing? It's so annoying. Why is there this overflow? Well, that's because the total width of your columns plus the gaps has already exceeded 100%. So there's this unwanted overflow. So you probably, we probably should account for that somehow. But it's cool because we have like things like the calc function. So you take 100%, then you minus the total width of the gaps, which is 60, and then you divide it by 4, and then no more overlap. But look at the code. This is spectacularly not dry and very long. So what we have to help us in Grid, there is a repeat function. So what the repeat function does, it helps us simplify the code. Turn that on. It simplifies the code because it allows you to repeat patterns of grid row or grid column sizes. So it takes in 2 arguments. So the first argument is the pattern that you want to the first argument is how many times you want to repeat, and the second one is actually the pattern that you want repeated. So this is the pattern that we want repeated. I'm like, I want it 4 times. So repeat 4 times this pattern. Okay, so we have dried up the code, but this is still a bit ridiculous, right? Can you imagine having to update this code with new calculations every time you want to, I don't know, change the size of the gap or you want to change the number of columns? Also, the browser's much better at me than math. Why am I the one doing the math? This is totally wrong. And so we have an FR unit. So an FR unit is, okay, this is for the next demo. So I'm going to turn this off for now. But the FR unit is a flexible length unit, which actually allows the browser to take over the math for us. It represents a fraction of the leftover space in a grid container. So the advantage of letting the browser figure out how to handle space is that we don't have to manually calculate everything ourselves, and it also reduces the odds having layouts break when you hit certain edge cases. I'm a very strong proponent of just let the browser do the maths, you know what I mean? Well, so far the grids have been empty, so we gotta put some items in them. So I'm gonna put these 4 items in them. So we're gonna talk about grid placement now. Without doing anything, it's very normal behavior for items to be laid out one after another. But let's say the magic of grid is that it's the placement, that you can place items in cells however you want it, up, down, left, right, and it'll fit nicely. So by default, auto placement happens when there are no placement properties on the children, and they'll all take up one grid cell. But once you start doing placement properties, and placement properties means that you're telling your item like you start from this row number and this column number. So we'll use grid columns to tell my item, here A, that you should start from the 2nd line and end at the 4th line. And you should start at the first row line and at the 3rd row line. So these are so A now is a placed item. And so it has taken up space right in the middle. There were blank spaces around it. And so because B, C, and D don't have placement properties on them, they fill up in the expected order. So that's pretty much how it works. So if you have, now that you're able to place items, right? Overlapping grid designs are now much easier. Because as long as you specify the row and the column value, the browser knows what to do with the item. And the stacking order also follows the source order. So A, B, C, D, that's why A, the blue one, A is at the bottom of B. So it's pretty intuitive. And you can change this if you change the z-index. But for the most part, the behavior is kind of within expectations. So overlapping designs, you don't have to wrangle with negative margins or absolute positioning, which messes everything up. You can just use a grid, and you can do this pretty nicely. And the last thing that I want to highlight from the long list of grid features is actually named grid areas. So I'm just going to highlight. I might go over time, so turn this back on again. Having named grid areas is great for responsive design because after you've defined your columns and rows, you can kind of give specific spaces area names. And to use it, you just tell your grid children like, okay, you go to area A, area B, and you can name it whatever you want. You could use emojis even for this. But basically what you do is that you send your grid item to their allocated area. So for D, it doesn't have an area. It goes by the auto placement algorithm. It's like the first free space, I'll just sit there. So this is great. Why? Because when you have a responsive design that you need to change the layout at different breakpoints, instead of having to modify each of your individual grid items, and sometimes you might have a lot of them, you can kind of do it from the top down. At the grid level, you change where the areas go. So I'm gonna try to show this. Okay, the last one we need to cover, oh, I'm running out of time. Alignment. Alignment is kind of like the magic sauce that glues everything together because alignment properties allow you to do adjustments. And that's pretty much what we want in a web design, right? We want to adjust things correctly. Alignment properties for now are only available for Flex and Grid, but there is discussion on getting this for like all the layout models in the future. So fingers crossed, that will be coming. But for the most part now, there are 6 box alignment properties. Grid can use all of them. Justify items and self are not applicable for Flex, and I'll explain soon. If you look at the content ones, so these first 2 content ones are for moving all the content within free space in the container. The items ones are to adjust the items themselves within their allocated spaces. So that's why for Flex it doesn't work. For justify items and justify self. For Flex, if we go back to this, you'll see that Flex items are all flush up next to each other on the main axis. And because of that, there is no free space along the main axis for them to be justified. Cross-axis, yes, they can move up and down. So that's why when you use justify items and justify self on Flex, there's no effect at all because there's nothing to be justified. Align works though. And the self ones essentially work exactly the same as the items, except that they're for individual items. So justify items moves all the items together. It's like, all 6 of you go up, all 6 of you go down. But if you want, like, out of your 6 items, you need 1 to be different, you use self. So that's how the alignment properties work. I was hoping to have enough time for this, so let's go through this as quickly as I can. I wanted to show a demo that put all of it together, and so I'm just gonna like really quickly run through this. I'll share all of this online. This is not just on my computer, so you can play around with it if you're interested. I made this kind of a pseudo hotel layout thing with all the properties that I talked about. It's fully responsive, so it kind of shifts at the different sizes, and I want to kind of briefly talk about how this was relatively intuitive to build. So for the header, I went with Flex because I have this logo that's pretty tall, and this button is much smaller. So in order to align it easily, I just went with Flex, and so put Flex on, and then just made the can't find it. Yeah. Made my align items centered, because like without it, you see that's what happens. So this was much easier to align than with not Flex, but the main meat of it is this grid here. So what I did for this is I did the named areas thing that I talked about earlier, whereby instead of adjusting each of the individual items at the different breakpoints, I just set that this element needs to go in this area. And it will always be in that area regardless of the viewport size, because what's changing is the actual grid layout itself. So at the widest, I have a 12-column grid. I've allocated the areas accordingly like this. As we go smaller, it hits an 8-column grid. And so the items are shifted on the grid itself. Again, the grid item themselves, you know, they're still allocated to their same areas, but the areas themselves have changed. So you can change the number of columns and then change the alignment. Another viewport, boom, 4 columns, no problem. Change the just change the areas again. I think I have one more. Yeah, that's the last one. So what this allows you to do is, it's the mental model now for building layouts with grid is that you can have a big picture view of everything at all the different viewports. And this, I feel, yes, it will take some time to get used to, but once you're used to it, you'll find that it's more intuitive than what we've been using all this while. So anyway, this is, I'm way over time, so I'm gonna end it off here. But I'm hoping that what I've covered today kind of helps you get a better understanding of the layout properties that we have today. And I'm hoping that building layouts will be a more pleasant experience for all of you in future. Thank you so much for listening. Dziękuję.